Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have discussed tips for solving numerical problems. Tips for solving numerical problem related to chemical thermodynamics. Now I will continue. Today some points requires a special attention that I am going to discuss. Some points requiring a special attention. First point, that is the internal energy, E. Internal energy denoted by capital E is a state function, but work, that is the W, and heat, that is a Q, are not. These are not the state function. E is internal energy is a state function. Capital E, internal energy is a state function, but work and heat are not. Work and heat are not a state function. This is important. However, Q plus W means heat plus work done is a state function. E is a state function, but W and Q are not the state functions. But Q plus W is a state function because it is equal to delta E, which is a state function. Q plus W, that is equal to delta E, first law of thermodynamics. Hence Q plus W is a state function, but not W and Q, that is the heat and work and heat is not the state function, but Q and W, if you add, that is equal to delta E, that is a state function. Next, internal energy of an ideal gas depends only on temperature. Hence, for an isothermal change of an ideal gas, delta E is equal to 0, because delta E depends on the temperature. Internal energy of an ideal gas depends only on temperature. Hence, for an isothermal change of an ideal gas, delta E is equal to 0. Hence, when we will put for delta E is 0, then delta E is equal to Q plus W. It means Q plus W is equal to 0, means Q is equal to minus W. This is an important point, that internal energy of an ideal gas depends only on temperature. If there is no change in temperature, then delta E is equal to 0. Then you will get Q is equal to minus W. After putting the value of delta E in the equation of first law of thermodynamics, that is that delta E is equal to Q plus W, delta E is equal to 0, hence Q is equal to minus W. Now, next important point, temperature and pressure are intensive property. Temperature and pressure are intensive properties. This is the important things, because these are not depending on the amount of the substance. Okay. Intensive property does not depend on quantity of the substance. Extensive property actually depends upon the quantity of substance. Now, next point, according to latest SI convention, international system, according to latest SI convention, SI International System, by first law of thermodynamics, according to latest SI convention, first law of thermodynamics, that is the delta E is equal to Q plus W, means work done on the system is taken as positive. Work done on the system is taken as positive. According to old conventions, in which work done on the system was taken as negative, that is the delta E is equal to Q minus W. This is according to old conventions. But according to new conventions, delta E is equal to Q plus W. Next point, the standard enthalpy of formation of a graphite is taken as 0, but that of a diamond is not 0, but equal to 1.896 kilojoule per mole. This is a very, very important point. The standard enthalpy of formation of graphite is taken as 0. For graphite, it is taken as 0, standard enthalpy, but that of diamond is not 0, but it is equal to 1.896 kilojoule per mole. Now, next point, bond dissociation energies of 4 CH bonds in CH4 are not equal. CH4, 4 bonds are there, CH, 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 CH. Correct? Then bond dissociation energy of 4 CH bonds in CH4, methane, CH4 means methane, are not equal. Hence, an average value is taken. Correct? Because all 4 bonds bond energies are not equal. Bond dissociation energy of 4 CH bonds in CH4 are not equal. Hence, an average value is taken. Next point, in gaseous reaction, entropy increases when Np is greater than Nr. N means number of moles, P means product, means number of moles of product. If number of moles of product is greater than number of moles of reactant, Nr, small r, R means reactant, and small p means product, then in gaseous reaction, if you can say in a gaseous reaction, entropy increases when Np is greater than Nr. Np means number of moles of product, a small p, and Nr means number of moles of reactant, a small r. This is the condition. Example, PCl5, dissociation of PCl5, it breaks into PCl3 plus Cl2. PCl5 is gas, but when it dissociates, it gives 1 mole of PCl3 gas plus 1 mole of chlorine gas, means 1 plus 1, 2 mole. 1 mole of PCl5 gives 2 moles of product, PCl3 plus Cl2. Second example, N2O4, that after the dissociation it gives 2NO2. Here again 1 mole is converting into 2 moles. Correct? Hence, in a gaseous reaction, entropy increases when Np is greater than Nr. In these two cases, entropy increases because number of moles of products are more than reactant. Next point, absolute value of internal energy. Absolute value of internal energy, enthalpy and free energy cannot be determined. Again, you listen carefully. Absolute value of internal energy, enthalpy and free energy cannot be determined, while absolute value of entropy of any substance in any state at any temperature can be determined. Means this entropy can be determined. Absolute value of entropy can be determined. Correct? Absolute value of entropy of any substance in any state at any temperature can be determined. But internal energy, enthalpy and free energy cannot be determined. Next point, a standard enthalpy of formation and a standard free energy of formation of an elementary substance is taken as 0. But a standard entropy of even an elementary substance is not 0. Very, very important point. Okay. A standard enthalpy of formation and a standard free energy of a formation of an elementary substance is taken as 0, but a standard entropy of even an elementary substance is not 0. Okay, question is asked. Now, next point, 1 calorie is greater than 1 joule and 1 joule is greater than 1 erg. This relation is also useful. 1 calorie is greater than 1 joule and 1 joule is greater than 1 erg. Next point, contrary to expectation, when a rubber band is stretched, entropy decreases. Why? Because the macromolecules get uncoiled and hence arranged in a more ordered manner. That is, the randomness decreases. If you will see that rubber is stretched, rubber band is stretched, then it should this increase, entropy should increase, but not like this. Actually, when it is stretched, when rubber band is stretched, entropy decreases. This you remember, question is asked. When a rubber band is stretched, entropy decreases. Why? Because the macromolecules, rubber is macromolecules get uncoiled, and uncoiled means arranged in a more ordered manner, and more ordered manner means entropy will decrease. That is, the randomness decreases. This is very, very important concept. Now, when an egg is boiled, then what happens? The entropy increases or decreases? When an egg is boiled, the entropy increases. Why? Because denaturation occurs, resulting into a change of protein from helical form into random coiled form. Okay, this is again important questions. You remember, when an egg is boiled, the entropy increases because denaturation occurs, resulting into a change of proteins from helical form into random coiled form. Next important point, during isothermal expansion, of an ideal gas, delta E is equal to 0, delta T is equal to 0, correct? Because you are talking about isothermal, means temperature will not change. Then when temperature will not change, then internal energy will not change, means delta E is equal to 0 and delta T is equal to also 0. Hence, H is equal to E plus PV. We know H is equal to E plus PV. So that delta H, that is equal to delta E plus delta PV, or delta H, that is equal to delta E plus P into delta V. Here PV is equal to RT. PV is equal to RT. Also you can tell nRT for n moles. Then delta H is equal to delta E plus nRT or delta nRT. Means you can write delta H is equal to delta E plus nR delta T. Also you can write, because temperature may change. R value is constant. N also for a particular reaction it is a constant. Then delta H is equal to delta E plus nRT. nR delta T you can tell. Then now you put the value of delta E. Then delta E is equal to 0 and nRT. Here delta T is again 0. Then 0 into nR, that is a 0. It means delta H is equal to 0. That actually I wanted to discuss. During that isothermal expansion of an ideal gas, because delta is equal to 0, delta T is equal to 0, hence delta H, that is equal to delta E plus nRT delta T. Then here delta E is 0 and delta T is 0. Hence finally you will get 0 plus 0, that is equal to 0. Hence delta H will be 0. Delta H is equal to 0. Hence enthalpy remains constant. Enthalpy remains constant during isothermal expansion of an ideal gas. Question is also asked. Then you should know, during isothermal expansion of an ideal gas, enthalpy remains constant. Next point, delta H is equal to delta E plus P into delta V. Here in bomb calorimeter, delta V is equal to 0, no change in volume. Hence, we should have delta H is equal to delta E in bomb calorimeter. Whatever value you are getting for change in internal energy, that is equal to delta H, change in enthalpy. Delta H is equal to delta E plus P into delta V. In bomb calorimeter, delta V is equal to 0. Hence, we should have delta H is equal to delta E. However, this is not true. This is not true because the relation delta H is equal to delta E plus P into delta V holds good only at constant pressure. Correct? This is the condition. I told you delta H is equal to delta E in bomb calorimeter because delta V is equal to 0. However, this is not true. This is because the relation delta H is equal to delta E plus P into delta V holds good only at constant pressure. At constant pressure only, you can say delta H, that is delta is equal to delta E plus P into delta V. It applies only, it holds good only at constant pressure. Correct? If pressure is constant, then this relation will work. Delta H is equal to delta E plus P into delta V. But here, when delta V is equal to 0, then V is related to pressure. That is not applying here. Hence, in that situation, when pressure is not applying, delta H is equal to delta E. Correct? Now, if you want proof also you can understand that H is equal to E plus PV, or delta H is equal to delta E plus P into delta B plus B into delta P. Means you have expanded H is equal to E plus PV. Now, you can also write, for H you can write delta H, for E you can write delta E. Now, PV is there. Now, you can differentiate it. Okay. First to make P constant. Then if you make P constant, then it will be P into delta V. And if V is constant, then it will be V into delta P. Correct? Hence you can write for PV, now two terms you can write. If P is constant, then P into delta V. Plus if V is constant, then V into delta V. Correct? Hence you can write delta H is equal to delta E plus P into delta V plus V into delta P. Okay. Then now you can get two equations. At constant pressure, when pressure is constant, that time delta P will be 0. Then what you will get? Delta H is equal to delta E plus P into delta V. Because pressure is constant, then in the equation P delta E plus P into delta V plus V into delta P. Here delta P is 0 and this term V into delta P will be 0. Then what will remain? Delta H is equal to delta E plus P into delta V. Correct? Then this happens at constant pressure. Now at constant volume, delta V will be 0, then P into delta V will be 0. Then what you will get? Delta H is equal to delta E plus V into delta P. Correct? Delta H is equal to delta E plus V into delta P you will get, because here volume is constant. Hence second term will be not there. It will become 0. Then delta E plus V into delta V, delta P will remain. This is actually proof. Okay. Now I am telling you, you should know that that is the some things you should know. Many students will be not knowing. We know that entropy is a measure of disorderliness. Generally, all students will know. Entropy is a measure of disorderliness. This will tell about measurement of disorder. How much they gone disorder. But here new things I am telling you. Entropy is also a measure of unavailable energy. Unavailable energy. Unavailable energy equal to entropy into temperature. This relation you keep in mind. Unavailable energy means unavailable energy is equal to entropy into temperature. Okay. Then entropy is also a measure of unavailable energy, not available. Unavailable energy, and unavailable energy is equal to entropy into temperature. Now another important point you might be not knowing, now you should know. Contrary to the third law of thermodynamics, what third law is telling against that? Contrary to third law of thermodynamics, some solids do not have zero entropy even at absolute zero. Third law tells about this only, that at absolute zero, entropy will be zero. This is the third law. But some solids do not have zero entropy even at absolute zero. Examples: glassy solids. Second example, crystals of carbon monoxide gas, nitric oxide gas means NO. Third example, N2O, nitrous oxide. Correct? Then carbon monoxide, nitric oxide and nitrous oxide, and solids containing mixture of isotopes, as for example chlorine gas. Okay, solids containing mixture of isotopes, their entropy is not zero even at absolute zero. Question is asked. Then example I am telling you, whose entropy is not zero even at absolute zero. Generally it happens for crystalline substance, but exception is there. Then glassy solid is example. Crystal of CO, NO, N2O, etc. And solids containing mixture of isotopes. Example chlorine. They don't have zero entropy even at absolute zero. Next important point I am telling you, the compounds whose enthalpies of formation have positive value are called endothermic compounds. Means delta H is equal to positive value, some positive value, then it is called endothermic condition. And those having a negative value, means delta H is equal to some negative value, minus 300, minus 400, like that way, that is called exothermic compound. Endothermic compound and exothermic compound. The compounds whose enthalpies of formation have positive value are called endothermic compounds. Reaction is different and compound is different. Now I am talking about the compound. Reaction, you know, that the reaction in which delta H value is negative, that is called exothermic reaction. And where delta H is positive, that is endothermic reaction. Here I am talking about the compound. The compound whose enthalpy of formation have positive value are called endothermic compounds, and those having a negative value are called exothermic compounds. Okay. Then today I am stopping only here, and next class again I will discuss some points that is related to competition. Correct? Now I am stopping only here. Thank you.